morning, I am Don Andre Di Malibot from 12 STEM 9, and today I will discuss to you about the significant figures. There are 4 rules in determining how many significant figures are in a number. First rule, non-zero digits are always significant. Example, 3 significant figures, 1, 2, 3. Second rule, any zeros between 2 significant digits are significant. For example, 4 significant figures, 1, 2, 3, 4. The third rule is, a final zero or trailing zeros in the decimal portion only are significant. For example, 5 significant figures, 1, 2, 3, 4, 5. Kaya siya counted kasi yung 0, katabi siya ng decimal point, nasa kanan siya. The fourth rule is, any zero after the first non-zero digit is still significant. The zeros before the first non-zero digit are not significant. For example, 1 significant figures. Kasi 1 lang siya kasi ito, nasa rule number 4 siya. Kaya 1 lang siya, 8. 1 significant figures lang siya. Katulad nito rin sa last number, 2 significant figures. Hindi to counted, ito lang yung makakount. What is matter? Matter is anything that has mass and takes up space. What is mass? Mass, a measure of the amount of material the object contains. Second, volume. What is volume? A measure of the space occupied by the object. There are 2 types of properties. The first one is the physical properties, directly observable or measurable without having to change the identity. Example, color, hardness. Second one is the chemical properties, a property that can only be observed by changing the composition of the material. Example, ability to burn, decompose, ferment, react with, and etc. Physical change will change the physical properties without changing the composition of the material. Example, boil, melt, cut, bend, split, crack. Chemical change, a change where a new form of matter is formed. Example, rust, burn, and decompose. Signs of chemical change. First, change in color or odor. Second, formation of a gas. Third, formation of a solid. Fourth, change in light or heat. There are 2 types describing matter. First, the extensive. Extensive depends on the amount of matter in the sample. Example, mass, volume, and calories. The second one is the intensive. Intensive depends on the type of matter, not the amount present. Example, hardness, density, combined, and extensive, and boiling point. This is the preview of classification of matter. All matter can be classified as either pure substance or mixture. Pure substance can be classified either as element or compound. Element. Element is composed of identical atoms. Example, copper, wire, aluminum foil, and gold. The second one is the compound. Compound is composed of 2 or more elements in a fixed ratio. Example, table salt. For mixture, mixture is made up of 2 or more substances. It can be classified as homogeneous mixture and heterogeneous mixture. For homogeneous mixture, it looks uniform all throughout. For heterogeneous mixture, it looks non-uniform all throughout. Homogeneous mixture, example, coffee. And for heterogeneous mixture, example, salad. There are 2 types of heterogeneous mixture. First is the colloids. Colloids is a mixture in which one substance of microscopically dispersed insoluble particles is suspended throughout another substance. Example, milk. The second one is the suspensions. Suspension is a heterogeneous mixture in which solute-like particles settle out of a solvent-like phase sometime after their introduction. Example, salad dressing. The next one I will be discussing to you is the atomic number of the elements. Atomic symbol. A is for atomic mass, C is for charge, and this one is the element, and Z is the atomic number or number of protons. Next one, atomic mass is number of protons plus number of neutrons. And for the charge, number of protons minus the number of electrons. Example, number of proton is 11 and number of electron is 10. Cation, 11 minus 10 equals 1. The next example is an ion. Example, the number of proton is 17. The number of electron is 18. Number of protons minus the number of electrons. 17 minus 18 equals negative 1. The atomic number of an element is equal to the number of protons in the nucleus of that element. The atomic number of an atom determines which element the atom is. Atomic number. Every atom with an atomic number of 1 is a hydrogen atom. There is 1 proton in the nucleus. The next one is uranium. Every atom with an atomic number of 92 is a uranium atom. There are 92 protons in the nucleus. That's all. Thank you.